Okay, hello everyone. Good evening and welcome to this month's GDG. Hello everyone. Okay. Hello everyone. Good evening and welcome.
Hi, folks. Sorry about that. It looks like Basani was kicked off the internet, but we hope to get him back soon. In the meantime, let us know in the chat where you're coming from. Cool. I'm seeing a lot of interesting places: Dubai, Pakistan, the Absa building in Joburg. That's really cool. Keep on sharing in the chat, and Putsani is going to be here in a second. Okay, here we go.
Okay, sorry about that. But yeah, welcome everyone. And then I hope you do enjoy this meetup. And we have lovely speakers who will be talking to us about the latest announcements from the Google I/O. So yeah, let's get started. What is GDG? It's basically a group of us developers who are interested in learning about the new Google development technologies such as Firebase, Angular, TensorFlow, Flutter, and so on and so on. And then for our Johannesburg GDG, we meet once every month, every first Wednesday of the month. And you can find about us on this link here. And then you can also follow us on Twitter at GDG Johannesburg and also on Instagram at GDG Johannesburg. Or feel free to email us at gdgjohannesburg@gmail.com. And as we go on about our meetings, we have a code of conduct that we try by all means to follow. And by you attending this meetup, you are key to adhere to our code of conduct, which can be found on this link here. But to sum it up, we just expect everyone to be nice and assume positive intent and make it a harassment-free event for everyone. And if you think one of our attendees is not living up to the code of conduct, please feel free to email us at gdgjohannesburg@gmail.com. And our meetups are made possible by our awesome sponsors. And speaking of the sponsors, we've got a brand new sponsor from this month, BBD Software. Big shout out to BBD Software. They'll be helping us with purchasing of the speaker gifts. We also have Overson and JetBrains. They've been our sponsors for some time now, and they've been helping us with awesome prizes. And we also have Retro Rabbit, who help us with paying for our streaming services. So if you'd like to be one of our speakers on our meetups, please feel free to send us an email at gdgjohannesburg@gmail.com or drop us a DM on Twitter at gdgjoburg. We welcome both new and experienced speakers. Cool. So on today's agenda, we have two amazing talks from very good Google developer experts. First of all, we have Eliza. She's a Google developer expert for Google Assistant. She'll be talking to us about the basics of designing and building conversational apps. And also we have Joe. He's a Google developer expert for Android and Actions. He'll be talking to us about adapting Jetpack Compose into our existing applications. So, Eliza, please go ahead.
Hello, everyone. So, first of all, thank you for having me over here, and I'm very excited to join you today. Let me share my screen. Can you see the presentation?
Yes, we can see. Thanks.
All right. So today we're going to talk first of all about the Google Assistant and specifically how you can make apps for that and also voiceify your existing web and Android apps. A bit about myself. My name is Elisa Camber and I work for Pixplicity, which is a creative tech agency in the Netherlands. I am a Google developer expert on the Google Assistant and also a travel addict when this is possible. If you want to follow along or if you want to find this presentation again at any point, this is going to be the link for the slide deck. I'm also going to be posting this on my Twitter if you want to find it again. So today's agenda, first of all, we're going to see why it's important, why voice is important, and why you should bother about making apps for it. Then we're going to talk about the voice user interaction or the VUI. It's very it's the user interaction for the equivalent of the graphic user interfaces that we have when you have a screen. But we're also going to see how you can actually design for it. Then we're going to see the Actions Builder, which is actually the platform where you can create all the conversational apps. We're going to see how you can voiceify your existing web and Android apps. And we're going to have some time for questions at the end. So virtual assistants, it's basically for companies, theoretically, but practically it's just two. It's Amazon and Google. So this is already for 3 years ago, and 4, sorry. Both of these companies win and lose ground every time. So it's not just that Alexa or Amazon or Google is big at this yet. They're both desperately trying to embed their assistant, though, in every platform that there is over there. So at the CES 2018, the assistants were a big thing, like a huge thing. And you can see here that the strategy, as they said, for the Alexa, for instance, is that we want Alexa everywhere. But what happened after that? So 2021, and this is the compound annual growth rate that is at 12%. And then that translates to a 4.12 billion incremental growth. So as you can see, during those 3 years, it actually accelerated massively and it turned out pretty well. And for this year's growth, it was at the 7.65. But let's see what happened at the CES that happened this year. So if you don't know, the CES is one of the biggest technological events out there, and all of the big companies are actually making massive announcements there. So Google Assistant and Alexa were invisible and everywhere at the CES. But what does that mean? Amazon and Google opted to skip joining the list of exhibitors at this year's all-digital CES, but their respective voice assistants erased what would normally be a glaring gap in the event's list. Alexa and Google Assistant, it appeared over and over as close to 2,000 companies showcased their products. This year has decisively proven that Alexa and Google Assistant no longer require active boosting of the show to play a part. Attendees can hear the voice assistants everywhere. So, from standalone devices to cars, to earphones, and even bathtubs, you name it, it's there. And it's within earshot to hear what you're saying. But why do all of the companies, and mostly those two, trying so desperately to get their assistant within an earshot? Well, it's not really a secret. It's more natural for us to actually talk to something or someone than go grab a screen and start typing to that. This is the first thing that we know how to communicate. This is the first thing that we learn in our lives to begin with. And because time is money, and you don't have to stop whatever you're doing when you're talking to a device, and I mean whatever you're doing, voice is just a much more simpler interaction with devices. And this is why we'd rather repeat 3 times what we say than actually get out of the bed and get our phone and tap on something or trying to find something online. But why should I, as a developer, care about? Well, for the same way that, for the same reason that you cared when you started building mobile apps, for instance, or even apps for wearables. It's just the new thing. Siri, Cortana, Alexa, and Google Assistant are just the beginning. Voice is the future. But how difficult is to build something for voice? So let's say an example over here. If I have the screen and I can just tap on something, then it's straightforward. It's either the first button or the second button. But if I have to communicate which button that you should actually tap on, then I could say tap on the button that says 1, or #1, or the blue button, or the top button, or a million other new commands. And this is all something that a human would understand very easily, but a machine, not that much. So we have a new user interface, and it's called the voice user interface. It's much more different from the graphic user interface that we had with the screens, but the principles are pretty much the same. And the fact that we don't have a graphic user interface doesn't actually mean that we don't need to design. Actually, it's the exactly opposite. We need to design even more, because now it's not that easy for the user to see where he or she should go to. So because the conversation is something that we start to do from the very early on in our lives, there are also some conversational basics that we don't know that we actually know. And those are the turn-taking, context, threading, and reading between the lines. And those are also the 4 main things that the assistants or any voice app actually struggles with. It's something that it's very natural to the humans, but the machines cannot really properly handle yet. Of course, there are a lot of things that you can do to make that better, but this is what we're designing for, because we need to make sure that the lack of those 4 principles is not going to be something breaking for the user interaction. So conversational apps are also called agents, and those that are specifically for the Google Assistant are called Google Actions. And those actions are just modules of the language natural understanding process. Let's see how the flow is. So the user will just give the input. This is going to be either through the voice or through the keyboard. And then we're going to the actions on Google. And this is what we're building, like the yellow part over there. So the actions on Google will get the query, and then it will turn into an intent of the user. And that intent will get you actionable data. That data you can manipulate through code, either get more information from the database or from the external APIs, and then you can respond to the user through the output. There are quite a few steps when we design for a voice user interface. And I'm not going to go into the details of everything, but there is a great documentation. I'll show you the link later on. We're just going to see some very basic steps when we're starting to build a voice or a conversational app. So first of all, we need to write down all the actions that our actions on Google should do. After that, we need to create a diagram. And this is just a decision tree for the actions. Then you have to decide if your app actually needs a backend, like if you need something from a database, for instance, some more information. Then we're going to design our UX. We're going to create the backbone of the app. Then we can create the actions on the actions builder. We're going to test this. Then we're going to connect the webhook, and then we're going to test again. So we're going to see some of those steps, but not very much in depth. Let's start with the first one. So let's assume that we have an agent or conversational app that it's a tour agency guide. So over there, like we want to have some actions, like we wanted to be able to fulfill some of those actions. So what we're going to do first is that we're going to write down all of the actions that we wanted to do. So this is, for instance, to book a tour or to find available tours or to find information about specific tours or a monument or timetables or pickup points and probably a million more. And you have to decide on which of those you have to start first. So you don't want to make something massive altogether. You want to break it into smaller parts first and make sure that those individual parts actually work and do some error handling before you continue on. After that, we're going to create the diagram that we saw, like the decision tree. So first of all, we have some entry points. The entry point that we see over here is the available tours, for instance. Do you need available tours? Yes or no? What do you do when the user says yes or when the user says no? And you're going to start from some very basic actions from over here. And as you continue with the rest of the steps that we're going to see later on, you will continue to iterate and develop this decision tree to actually cover all of your use cases. This also is going to be translated basically to the code that you're going to need later on. So if you have a compact structure, like a decision tree, then it's going to be much easier to start with that to the coding part. And then the chances are that you're not going to be missing any massive error handling when you have this decision tree. Then we said that we are going to be deciding on the backend. So if I have a virtual agent or a virtual assistant for a tour agency, then we do need a webhook because we need to get, for instance, all the available tours. And we're going to use the inline editor that the Actions on Google is offering. We're going to see that later on. And then we have to design the UX, which is the most important step from the entire design process. So there's still a few steps over here. So first of all, we have to pick the right use cases, and then we have to write them down. We create the persona of that agent from those use cases. Then we write some simple dialogues. We test it out with other people as well, so that like when we ask something, maybe we get a response that you're actually not expecting, and then you can just continue to develop your decision tree, and then we build on top of that. So what are the good use cases? So before seeing, well, to actually understand what a right use case is, we need to understand what the wrong ones are. So if you ask for something, what's your frequent flyer number? Like, you don't want to ask questions that are optional. Sure, I'll book the flight. I need your frequent flyer number first. You don't want to block an action for optional information, like the postcode, for instance. Like, you can find these things with other information. To check if this product is compatible with your PC, go to settings, blah, 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 blah. Well, I don't need a machine to tell me what to do if I have to turn on my computer. You need to have actions that actually make sense to have a conversation about them. To verify, tap on the top of the Google Home device. I mean, yes, these are quite extreme, but they're not really as extreme as they seem right now. So when you build a conversational app, you have to optimize for these three things. So first of all, speed, how fast you can get your user to the data that they're asking for, the simplicity of the interaction, and finally, the hands-free interaction. So we have use cases, and for creating use cases, you first need to create a few like simple users. So here, for instance, I have a Mary and she's CEO, and there are two scenarios for booking tours. The more of those use cases you have, the easiest it will be to actually find out which, of course, actions are important to start with. And then you can easily eliminate some of the mistakes that we saw before, like getting optional data, for instance. Then we have to create the persona of our agent. And the persona of our agent is basically the characteristics of it. Like, is it going to be cheerful? Is it going to be formal? It really depends on the use cases that we have. So for this agent, for instance, it has to be formal because the target audience is adults, basically. It has to have a very simple language. It has to be suitable for tourists. Tourists are not always very comfortable with the specific language that we chose. And it has to be engaging and fun. Like it's at the end, they're choosing this to have fun. It's a boat ride. It has to be fun. And maybe you can have some fun facts, for instance, for history or for some art lovers. And we then have to write dialogues for that. So you write sample dialogues for each of those use cases. And then you also write some sample dialogues for some error handling. So if you ask me, at what time do you want me to pick you up? And I say on Tuesday, this is something that your agent should be able to handle and to be able to repair this conversation. So in this example, I have the happy path. Hi, I'm your guided tour assistant. How can I help you? Is there a tour available for Wednesday at 5? Sure. It is a boat tour going through all the major monuments in Amsterdam. Pickup point is the central station. Book one ticket. Done. Booked a ticket for the Amsterdam boat trip for this Wednesday at 5 p.m. And you can see here that even if this is the happy path, you still have to confirm with the user that actually what they chose is what your agent understood as well. This is the link that I was telling you about. So we have the developers.google.com in the assistant. And it goes from 0 to 0. Like even if you're new to the conversational design or you're going to the error handling, this is the place that you can see anything design related. So it's showtime. And I'm going to go over here. If you can give me 1 second, please. All right. So this is the first thing that you see. I created a brand new project over here. And this is the very first thing that you're going to see when you create an actions from the actions builder. So a few things first. We have the scene. And this scene is the actions that we said before. So a scene would be, for instance, the available tours that we're going to create. Another scene could have been the information about the pickup points and stuff like this. So all of the actions need to have a scene. We also need to have a scene for a welcome and a goodbye. We then have some custom intents, which is basically when you ask something for the user and you're expecting back an answer, the custom intents is what you're going to have over there. And we also have some system intents that the user, the console is giving us. So we have the no match, for instance. If the user said something that doesn't match any of your scenes, we have the no input or the cancel. And this is already pre-made for you. And finally, we have the types, and the types are entities. So if I had available tours, for instance, and the one was a boat and the other one was a walking tour, then the boat and the walking would both be types. It's the parameters that we're trying to get from the user in order to understand what they're trying to do. So we're going to go over here and we're going to create a new scene. I'm going to say it available tours. All right. And I'm also going to create one that it's going to be a welcome screen. So I'm going to stay here in the main invocation. The main invocation is when the user says, like, talk to my app, for instance. And this is where it's getting invoked. So if we test this now, it's not going to do anything. And I can test that actually for you. And you will see that it's just going to end the conversation. The first build takes a while. Okay, that's too much a while. Let's create over here and let's hope that it's going to get better. So we go to the main invocation. And here we can see that when I say, like, okay, talk to my test app, it's going to say this over here. So the variant speech, start building your action by defining a main invocation. So instead of here, it's going to be a hello, I'm your tour agent. I forgot to escape that. Fine. Your tour agent. And then we don't want this to end the conversation. So what we're trying to go, what we will do is that we're going to go to the transition. And the transition is the action, what will happen, where it will go when this speech part is done. So here we are going to go to the welcome. And if I save this, now if I am going to talk to it and say, like, okay, talk to my test app, instead of just ending the conversation, it's going to go to the welcome scene. So the welcome scene, of course, doesn't do anything yet. So if I say on enter, send prompts, I'm going to do the JSON over here. So this is what it will say right now. And let's say, do you want the available tours? And we're going to save this. And then we, well, for this one, we're going to handle the two situations. If the user says yes, and if the user says no. So we are going to handle the user intent. It's going to be a yes. And the yes, it's going to transition to the available tours. And then we're also going to create one for no. And this is going to end the conversation. Normally, we would have another scene over there that I would say, like, at least a goodbye. But for the demo's sake, I'm just going to save it like this. So if I put over here on enter, it should say something. Okay, let's say fetching available tours. All right, and let's go test this one now. Finally. Okay, so I am going to talk to my test app. And it does another one too. Nope. Okay. So thankfully, I did create a backup project. And I hope that this one will work.
All right, let's get the test version of my test app. Hi, I'm your guided tours assistant. Do you need the available tours?
So if I tap over here, yes.
Fetching the available tours. I found 3 available tours for today.
So this is a few steps further than I want to show you, but we're going to see that now. So this is the same thing that I had before. So if we go to the welcome, we're just handling the intents and we send those to the available tours. And what we did before is that on the enter, we had the fetching the available tours prompt. So we said, though, that we actually have to fetch that. And we can't do that through this interface over here. So what we do is that we call the webhook that we have over here. And you can use either the inline editor or you can use any URL webhook that you want. So here we have, let me show you first, the call the webhook. You just give a name over here. I named it availability. So when I go to the webhook now, app handle availability, and then it also says this one. So it will also say I found 3 available tours for today. And this is how you basically switch between your actions builder and your webhook. And as you can see, it's actually very easy. And one last thing that I wanted to show you is that if you notice over here in my test.
All right, let's get the test version of my test app. Hi, I'm your guided tours assistant. Do you need the available tours?
So if you see over here, there are 2 suggestion chips. And these are super easy to actually add over there. So what you have to do is that you just go to your welcome intent, which is the first thing to be called. And here, nope, where is it? Symptoms, okay. So you go over here, and as you see, instead of just having the speech, you also have the suggestions over here. And this can be any, like this one is a yes and a no. You can also have a cancel or whatever. To add those, you actually have to just click insert over here. So last symbol, for instance, and the editor will just add it for you over there, and you don't really have to do anything else. And that would be just the demo, a very short demo, as you can imagine, for the actions builder. And I'm going to continue over here with the presentation. We also said that we do have ways to voicify basically our web apps and our Android apps. And why would we do that? Because as we said, we can have conversational apps, but only if it actually makes sense. Like if the user needs to have a screen, for instance, it doesn't really make sense for us to just have a conversation with them, because what if you need to show images, for instance, if you have a tutorial? So let's first see how you can voiceify your web applications. We have 3 examples over here, a news, a recipes, and podcasts. So for the news, you can see that it shows as a snippet over there. Then for the recipes, it's basically just the same, but you can also send it to another display. And then for the podcast, you can finally just click play. How you do that is that you send structural data. So you structure your data in that way that Google understands it, and they automatically create a conversational app for you. For the content types that you can do that is the podcast, the recipes, and the news that we saw before, the frequently asked questions, and how-to guides. This is also a how-to guide. So you see that at the beginning, we have the start the tutorial. So it's basically just an overview of whatever you will need or how much time it will cost you. And then when you start the tutorial, it will show you an image and a step-to-step guide. And this is automatically created if you structure your data correctly, so that Google just fetch that and show it to the user. And in between of the web and the conversational apps, we have something that it's called an interaction canvas. And the interaction canvas, it's not just like the snippets or the widgets that we saw before within the assistant conversation, but it's a full screen experience for the user. So it has 2 components. It has a conversational app that you can build with the action builder, as I did for the available tours, for instance. And it also has a web app. So it has a front-end web app which customizes the visuals, and it shows everything to the user. So how it works is that if I say turn the screen blue, for instance, the actions on Google, well, the conversational action is going to get the intent of the user, and it's going to extract the values that I wanted as it did before. The natural language understanding process is then going to switch to a callback, and that callback is going to call your interaction canvas API, which is within your web app. So once the web app gets this callback, the on-update callback will also get any data that you sent through the conversational app. And then it will just, once it's loaded, it will update the UI according to what the user has asked. And here is an example.
Which difficulty do you want to play? Normal. I like normal too. All right, let's see the drawings. Mouse. Vegetable. Marathon. Great job. That's impressive.
So you can see that every interaction is hands-free, and the user doesn't have to do anything. They just talk to it, and it will understand what the user is saying, and then it will automatically switches to the web app, and the web app will get that intent from the conversational app and actually do what the user has asked. And we also have a way for making the Android apps visible for the Google Assistant. And there are 3 ways in doing this. So first of all, we can display the app information on Google interfaces, which is the widgets, like we saw earlier for the web apps as well. Then we can launch features from the Assistant. So basically, you deep link to one part in the Android application. And you can also suggest voice shortcuts from the Assistant. So then you just get the context, and next time that the user wants something to be completed, then you can just remember how they did it before and just get that voice command from the user and basically deep link again on that specific part. So the example for the first one, the widgets, is this one. So while you're talking to the assistant, it just shows a widget over there. And for the second one, the deep linking, it shows like this. So it opens the application with the data that the user provided already filled in. So the amount for in this instance and the name. And finally, this is how you can create your own dynamic shortcuts. So you can suggest to your user that they can check the bits quickly with a shortcut. And then you just inform them that, okay, so next time just say, hey, Google, show my beats. It will just show your bits over there. This is also the flow. You can see that it's not very different from what we already saw for the web. So basically, the user will say something, the Google Assistant and the conversational apps will, well, we don't really have conversational apps over here. The Google Assistant and the SDK will just take care of everything. So then it will open your shortcuts.xml in your application. You will there get the intent and the data, and also how you want this to be fulfilled, if you want to just show a widget, or if you want to open your application. And then your Android app will tell basically the Google Assistant what it should do. So before wrapping this up, I would like to take any questions if you have.
Okay, thanks so much, Eliza, for that amazing talk. I learned so much. I'm sure everyone did. So I'm sure we have a couple of questions. The first one is that can we change the voices used during testing?
Yes, you can. I don't remember exactly how many voices there are available, but you can change the voices during that. And there is also one new, well, not new, but one more feature that is called the SSML. So basically, it's a markup for voice, and you can you can instruct the voice where it should pause or where it should emphasize, where it's like a paragraph change, for instance, so it will pause longer and stuff like this.
Awesome. Thank you for the answer. And then the second one is, if we have a backend service fulfilling the webhook that relies on an access token, can this be handled by the AOG console, or do we have to use something like an API key?
Well, the access token will be, I actually don't know the answer for this one. I can check that out though, and if you can drop me a line somewhere that I can reply back, I'll happily ask someone for this one.
Okay, nice. Thank you so much. And then the other one is, what is your favorite AOG, and what have you developed yourself that you're proud of?
I don't really have a favorite action. I really love some of the games that it has, but depending on what you want to do, then this is your favorite action at that point. So, for instance, I love when I can just tell Google to start my podcasts. For me, this is the one interaction that I always like to do hands-free, because when I listen to my podcast, I'm always doing something or I'm on the move. Something that I've developed more of myself, there are a few things that I've done for our office, but unfortunately those are under NDA. But I did make one app for myself, and this was basically to keep track of my dog's health. So when he should be getting his pills, when is his next vaccination, and sending reminders and stuff like this. So it was both a conversational app, but also mostly an Android app.
Wow, that's cool. I mean, I think, okay, we have another question from Katlejo. It says, can we specify the default language, like English or Zulu?
There are many languages that are supported. I'm not quite sure about Zulu, but yes, you can. When I switch back to my slides, actually, or to sharing my screen, I will show you that you can actually have the default language set to something different. But I also have multiple languages over there.
Awesome. Okay, another one is it possible to condition the device to someone's specific voice for the device to execute the command?
Some specific voice. I don't know. I haven't done that. I would be quite surprised if that could happen. Let me check real quick. No. So you set the voice through the settings, so there is no way for it to interact with your code.
Nice. Thank you for the answers. I think that should be all with the questions. I'm not sure if there's
All
any
right.
last one.
Okay.
Okay. Yeah, I think that's okay. So
Okay.
we have the last one, I think. Can we split the webhook to multiple regions?
No, but you can have you can short this out on your own server and then just set this as your webhook. So that should take care of everything else.
Awesome. Thank you so much, Eliza.
All right.
That was really amazing. Yeah.
Thank you. I'll go back to my screens for just 1 minute to wrap it up, if that's all right.
Nice. That's okay.
Okay. So over here, first of all, this is how you set the voice. As I said before, it's under the settings. So you can set it over here. And from here, you can also set the voices that you want. And if you go to the language settings, then you should see a lot of those. Zulu is not over here, though. Sorry for that. But you can also select multiple, as you can see. And if there are multiple locales, then you can just set it over here. And then you can just go over here and translate the languages so that, like the prompts, for instance, you don't have to go through the builder to set everything up. Okay, so I'll just go back. And let's see all that we learned today. So first of all, we learned why voice is important. And it is the future, and there are multiple studies and data to actually support this. Then we learned about the voice user interface and how we can actually design for an interface that there is no graphic, there is no screen. Then we saw the Actions Builder and how we can easily create our own conversational apps with the Actions Builder. Then we saw how we can voiceify our web and Android apps. And finally, yeah, I'll be around for any more questions if you have. You can find me also over here. And thank you very much for today's, for having me here today.
Thank you, Eliza. It was really amazing to have you talk to us. Okay, so the next talk we'll be having is by Joe. He'll be talking to us about adapting Jetpack Compose into our existing applications. Go for it, Joe.
Hey, how's it going? Yeah, really enjoyed that talk. It was great, and learned a lot. So yeah, it's all right to get started. I'll share my screen. Cool. Yeah, well, hey everyone. Thanks for being here today and thanks for having me speak. My name's Joe and I'm a Google developer expert for Android. And I'm here to talk to you today about using Compose inside of your existing Android apps. So there'll be some time for questions at the end, but you'll find my Twitter handle on each slide if you want to reach out on Twitter also. Cool. So when it comes to composing our apps, we're likely going to see one of two cases. So we're either going to be creating brand new features of Compose, so building Compose-only screens, or we might be slotting Compose into existing features of our app, or even using the Android UI toolkit inside of those Compose screens. So in many cases, a lot of developers will be taking this approach and introducing Compose into existing apps. In these scenarios, as tempting as it might be, it's unlikely that we're going to be rewriting every single screen from the Android UI toolkit to Jetpack Compose. There will be certain things that might become blockers or road bumps during that process. And while every approach is different, company focus, team size, any current projects, or so on, there are a couple of things that could actually make the incremental adoption a requirement. So to start with, there's still a bit of a learning curve with Compose when compared to how we are used to building Android UI. So being a completely different way of building UI components that also heavily relies on the architecture of the app, such as state management. There's a lot for teams to adjust to and then also work out how this fits into their projects. So while Compose adoption will help us move faster in the long run, we still need to deliver value to our users in the meantime. So dropping everything to adopt Compose might not be a practical approach for most teams, but being able to do so incrementally allows us to do so while still delivering this value. Here, it's all about being strategic about how we can move forward with Compose and then still get that value to our users during our adoption. And then also some things just aren't ready or maybe aren't available for us to use in Compose yet. So meaning we'll have to take a hybrid approach and fall back to the Android UI toolkit where it's required. And finally, we might have existing views that are not quite in a position to be converted to Compose yet. So this could be for any reason. Maybe a view is quite complex and would require a large amount of work to migrate. The work involved in that migration might not be the best use of our time right now. So we're going to need to find ways to work around that and still be able to move forward with Compose. So at the end of the day, there could be a number of reasons why, but being able to support a hybrid migration is a key feature of Compose that allows teams to move forward with Compose adoption while still being able to deliver value to our users. This unblocks us from using Compose while still allowing us to circle back in future and tackle these parts of our app whenever the time is appropriate. Now, in a lot of apps, we're going to end up using composables inside of the Android UI toolkit, as well as the Android UI toolkit inside of composables. So knowing about the tools that we have at our disposal are going to help us achieve these things smoothly. So we're going to start by looking at how we can use composables inside of our existing Android layouts. And this can be achieved with what is known as the Compose view. So the Compose view is an Android view class located inside of the Compose UI platform package. At a first glance, this looks just like any other view that we might come across when working within the Android UI toolkit. This class extends from another class which is known as the abstract Compose view, which we'll come on to a bit later in this talk. The extended class handles all of the complexities of this view, with a Compose view simply exposing a set content function which can be used to assign a composable to this view. So with that said, Compose view is essentially a view that we can use to display composables inside of the Android UI toolkit. The great thing is that because this is just another view, we can pretty much use it in a similar way to which we have been using existing views inside of our apps. So under the hood, the Compose view utilizes the lifecycle of the parent class so that composition can be tied to the lifecycle of that class. So for example, this allows for disposal of composition as required, essentially tearing down the view when needed. So as I mentioned, the Compose view is pretty much like any other Android view that we might currently be using in our apps. This means that we can add this view to our XML layout like so. Because of the nature of this view, as in it's used to display composable UI, there are no custom attributes that can be used to control anything around the composables inside of this view. So by adding this to an XML layout, we are essentially adding an empty placeholder which acts as a holder for composables. So instead, a composable needs to be applied programmatically using the set content function of the Compose view. So as we can see, when we call this set content function here, we pass a composable into that function, and then that composable will be composed inside of our Compose view and displayed within our UI. So here we've added a Compose view to our XML layout, and we've got a composable now showing inside of an Android UI toolkit class, which is pretty cool to see. So while working with XML layouts is fairly common inside of Android apps, it might not always be the case that we want to place a compose view in this kind of location. In other scenarios, we can add the compose view programmatically, just like we would do with any existing Android view class. So here, the behavior and configuration of the compose view would then remain exactly the same as when added via an XML layout. So we can use the set content function to assign a composable to the compose view. And being able to do this programmatically opens up opportunities in other parts of our code base too. So for example, outside of adding the compose view to an existing layout, we might want to do something such as returning it as a layout view from the onCreate function of a fragment. So this is essentially using the compose view as the layout of the fragment that's being used on screen. So this saves us inflating an XML layout, and we can, for example, maybe you're heavily invested in the navigation component with fragments. This allows you to keep that navigation stuff in place, migrate to compose inside of your UI, and then tackle the navigation at a later stage. So in your app, it might be the case that you end up using multiple compose views within the same layout. In these cases, you'll need to assign a unique ID for each one in order for saved instance state to work as expected. So this can be achieved by defining IDs within an ID resource file, and then using these IDs to assign an ID to each of the compose view instances. Doing so will help you to ensure that save instance state works as expected for your screen. So as we can see from the previous examples, the compose view empowers us to add composables to existing Android UI toolkit layouts, both programmatically or via XML. So in a nutshell, this view is essentially going to be used anytime you want to use a composable inside of an existing Android view class. So while that statement outlines a clear scenario, this can look different depending on the project and the team. So let's try to visualize some of these things. So maybe you're building a new feature, or even adding an existing feature, and you want to use compose inside of an existing layout. Maybe your team is learning compose and you want to tackle smaller and simpler parts of the UI before diving deeper into larger migrations. Maybe you are working with a complex UI and want to incrementally migrate an existing layout to compose. Or maybe a component in your UI is not yet supported by compose, or there are issues that are introduced when doing so. So these are just a few scenarios that come to mind. They all essentially link to the same outcome, being able to incrementally migrate compose inside of existing Android layouts. So now that we've got a better idea of what the compose view can be used for, there are likely going to be times when we need further support for composables inside of existing Android classes. For this, we have the abstract compose view class. So for example, while the compose view allows us to achieve the goal of inserting composables into existing Android layouts, there may also be times when we want to smoothly share custom Android view classes or even composable functions across different parts of our app. Things could also start to get a little complex when we try to work with other parts of compose, such as state, maybe more complex composables, or even views that contain a lot of configurable information. In these cases, it might make more sense for us to extend from the abstract compose view class ourselves instead of relying on the provided compose view implementation. So for example's sake, let's start with a minimal implementation of the abstract compose view. So at this point, we've extended from the abstract compose view, we've overridden the provided content function and provided a simple text composable. There's one problem here though. We don't have any content to provide for that text composable. And we don't have any way for an external class to provide a value for that text. In these cases, we're going to need an internal variable reference that can be manipulated and used to control the content of our composable. So here, we implement the text property of our view as mutable state. This means that our custom view can still be inflated and placed inside of existing layouts, but this time offering the ability to support some form of internal state. It's best practice in these scenarios to utilize mutable state of objects to ensure that the property is kept thread safe for compose. So with this in place, this can then be manipulated from our Android class, just like any other view class or binding. The use of this mutable state will ensure that recomposition will reflect any state changes for our custom view. So at this point, no, what is really the difference from when we were using the compose view? Like, couldn't we simply use the compose view and pass down the state into a contained composable? So what we want to quickly look at here is the composable content that is being used inside of our custom view. We can go one step further here now and split out the composable from our content function into its own composable function, allowing us to reuse this both as a composable function and a custom view class. We will then reuse that composable inside of the content composable function. Here, we now have the myCustomView class, which can be inflated into existing Android layouts, along with our myCustomComposable, which can be used within our composable UI. Being able to add this to a layout either via XML or programmatically means that we can abstract out the concepts of compose from our existing classes. So rather than needing to add a compose view and then sign a composables directly inside of existing Android classes, we can help to keep a clear line between composable UI and the Android UI toolkit within existing classes. So while the previous code snippets are just simple examples, there are likely to be cases where we are working with more complex custom views that may contain many mutable properties or need to hold some form of internal state. So to begin with, Compose View does not allow us to add any internal properties to a view, other than what might be provided by any contained views. While we could configure and maintain any of these properties as state or as part of the Android class that is using the view, we either might not be in a position to support that, and there could be a lot of code duplication for composables that need more customization. This could easily start to bloat our existing Android classes. There may also be some cases where it makes more sense for that state to be tied to the view, rather than at a global or screen level. Extending from the abstract compose view allows us to alleviate these concerns by giving us a place to hold these properties and have more control over the composable that we are providing. So along with this, the abstract compose view also eases the sharing of composables between both Android classes and composable UI. So while we could share a composable function between a composed view and composable UI, the abstract Android view can help to simplify the reuse of composables between the UI toolkit and composable UI. So for example, we may have a new feature that adds a shiny new composable to our design system. However, we also need to use that new component inside of other existing parts of our app. So while the compose view could be used to achieve this, with the details just mentioned, this could get a little complex. We would need to use our myCustomComposable multiple times inside of multiple compose views, to the point where we need some form of reuse to help smoothen our migration. To resolve this, we can split out our composable provided by the content function into a separate composable function, as we saw just now, helping to promote reuse both in our custom view and in our composable UI. If you're still wondering whether you should use the compose view or the abstract compose view, to be honest, the approach really depends on the application in your current setup. But as a general guideline, the way I'm currently thinking of this is the compose view is great for maybe one-off cases when the need arises to switch out existing views for composables, such as a custom view, or we need to house composables for the layout of a parent class, such as view holders and fragments. On the other hand, the abstract compose view is great for when we need to promote reuse of composables between composable UI and the Android UI toolkit. It also helps to abstract configurable information for a component, helping to keep a clear line of responsibilities between composable UI and the Android UI toolkit within existing classes. So now that we've covered use of composables inside of the Android UI toolkit, we're now going to flip things over and move on to how we can use Android view classes inside of composables. So the Android view is a composable function located inside of the Compose UI platform package also. This looks, again, just like any other composable function that we might be utilizing inside of our composable UI. Here, we can see 3 different arguments which the composable function requires. Now, if we're already working with Compose, it's likely that we've already been utilizing the modifier argument when using another composable function. Having this available for this Android view composable allows us to provide modifiers here, just like we would with any other composable. So this also allows us to keep any layout, styling, and other modification properties at that compose level. Now, this is an important thing to keep in mind when mixing the lines of compose with Android views. Maintaining these kind of attributes for your UI will remain smoother if Compose is managing as much of this as possible. If we are mixing this ownership between our composables and our Android views, we start to also blur the clarity of responsibilities for developers who are working with this code. So keeping these concepts at the compose level will also help your migration moving forward. So you won't need to double back on your work in future when you eventually come to migrating the rest of your screen to compose. So outside of the modifier, we have the factory and update arguments. These allow us to provide the requirements for creating and managing the corresponding Android view class. Starting with the factory, this is the block where we will provide the Android view class that we wish to use inside of the Android view composable. This factory block will be called a single time on the UI thread when the Android view is initially composed. Because this ensures that the view will only be instantiated a single time, you can also use this block to perform any other related initializations that only need to happen once. When this factory block is called, under the hood, a view holder is used to hold a reference to that view so it could be composed into the UI when it is required. Finally, we have the update block. This is a callback that is triggered once the view has been inflated, meaning that it can be used to set any kind of property data onto that view. So whenever any state changes inside of the Android view, the view will be recomposed. So however, at this point, only the update block will be called to reflect the state change. That factory block will not be called again. So meaning that the view reference that was originally created will be retained. So if you have dynamic content that you need to set on recomposition, this should live inside of the update block so that it can be recomposed when required. So when it comes to utilizing the Android view composable, we mentioned above how there is the potential to start blurring the responsibilities between compose and other Android classes. So for example, if a developer ends up working in a class that consists mostly of compose, touching on Android view concepts could add some cognitive overhead, as they would need to start thinking about compose and the Android UI toolkit. So in some of my own projects, I've been experimenting with splitting out my Android view usage into separate composable functions, allowing me to essentially abstract these UI toolkit references away from my compose code. This may not be necessary for Android view composables that do not contain a lot of complexity, but is a nice way to add a layer of abstraction should it be needed. We could then access this composable from within our composable UI, and that point of access knows nothing about the fact we are working with an Android view. In most cases, we will be working with individual composable functions anyway, so this will likely be a natural approach that ends up being taken for our composable definitions. So now that we know how to use existing Android view classes inside of composables, I want to take a quick look into a similar concept, which is embedding XML layouts inside of composables using view binding. So I'm not going to cover too much about what view binding is here or how it works, but if you're using view binding currently, you'll have this defined in your project. If you're not using view binding, you'll need to add this before you're doing so. So view binding is where you have an XML layout and instead of using Kotlin synthetics to access view IDE references, view binding will generate a binding class for you to access those IDs for it that way. So if you are using view binding, you'll also need to add a separate dependency to be able to access the view binding features within composables. With this in place, we can then start using the Android view binding composable. We can see that this looks very similar to the Android view composable that we looked at in the last section. So once the build tools have generated the binding class from your XML layout, you can use the Android view binding composable, providing the inflated view binding reference to the factory of the composable function. Similar to the Android view, we can then use the modifiers and update block to control the look and feel of the content for our composable. This composable then behaves exactly the same way as the Android view, with the only difference being the use of the inflated view binding. So if you're using XML layouts in your project and you want to use those to composables, this is a great way of being able to ditch custom view classes and relying on the XML layouts themselves. So when working with these different views and composables that help you achieve compose interoperability, we're going to be working with some form of state in our application, most likely. When it comes to compose, this is where things can get a bit more interesting. So compose thrives from having a single source of truth, which is even better when achieved through some form of unidirectional data flow. This means that your UI is composed from a single state object, meaning that the state of your UI will only ever be reflected by a single object state, making your composed state more predictable and also more testable. However, this definitely comes across as one of those perfect scenario situations. This would be an ideal world for sure. So in a lot of scenarios, our apps either may never use this kind of approach or might be in situations where we're kind of moving in that direction, but not everywhere in our app where we are using Compose is using that state management system yet. In these situations, we need to work with what we have and take certain approaches to make our state work well with Compose. And there's going to be a couple of scenarios here, and we're going to take a look at two of them. So the first is Compose being the source of truth for our state. So in these scenarios, the composable holds the source of truth, and we may need to communicate that state back to non-composed code. So if non-composable code is kind of managing the overall state of our screen, this is a good scenario to do that. So in order to share composable state with objects that are not being managed by Compose, there is a side effect composable which can be used. And this is a side effect is invoked on every successful recomposition. So in the example shown on screen, we have some form of state that is kept inside of the composable. This is represented by the isEnabled flag, which I've omitted how this is calculated, but essentially represents some form of state. Our composable takes a back dispatcher into its function. And what this composable needs to do is update this listener based on this enabled state. So here, a side effect is being used to update this value. So whenever a successful recomposition occurs for this composable, our external state outside of this composable will be kept in sync with what is inside of the composable. On the flip side, we might also need to work with the state being inside of the view system, something that we are likely currently utilizing in our Android projects. So for example, a lot of Android views hold their own state, which we access when needing such data, such as the text from a text view. In these cases, we can keep the composable state inside of the view system, treating it just like standard view state that we might see elsewhere in our apps. So in this example, we have a custom view which contains a text view, along with a text field composable. The text view is used to show the content that is entered into the text field. And because both of these have state, we need this represented within the view and for them both to be kept in sync. So here we use mutable state of for the composable state to ensure it is kept thread safe. This then allows us to keep this view state inside of our Android class and not have to keep it inside of our composable, as well as being able to then reflect this inside of the Android text view that is shown on screen. This gives us the result of reflecting composable state inside of our Android UI toolkit. So regardless of how you're working with state, there are several state-related functionalities that are available for data streams in Compose. So whether your app is currently utilizing live data, flow, or observables, these can be utilized as composable state using the corresponding functions that each of those provides. This means that recomposition can be triggered whenever these data streams are updated. It's worth checking out the corresponding Android X Compose runtime packages for more information on what is available here and how to use them within your apps. So during any of this migration, be it working with state or UI components, there's likely going to be some places where you'll need to call the Android framework from within Compose. There's a couple of talking points here that I wanted to mention before we start to wrap up this talk. So the first is context within Compose. As we are likely aware, we access the context in a lot of places throughout our Android projects. There are also going to be likely points in our Compose projects where we need to do the same. So in these cases, we can access the context using what are known as composition locals. Now, composition locals are used to propagate values from Android framework types to Compose, and this includes things such as configuration, view, and context. So you'll find these within the framework, and they're prefixed with local, so local view, local context, and so on. And then we can then use this for anything that might require a context. So for example, if we need to create an instance of an Android view class that we're going to use within our composable UI, we can use the context like so. And any other thing else that you need the context for, you can access it in this way. Now, before you start doing so, it's worth checking out what utility functions are available in Compose to save you repeating what might already be provided by the framework. So in Compose, there's a string resource composable, which you can provide a string resource ID, and it will fetch the string for you. Under the hood, this is using the local context to access the resources of your project. So it's doing exactly something you could do yourselves, but there's a collection of utility functions available to ease that process for you. So now that we know how to add Android views into our composable UIs, one thing we might need to be aware of is how to adhere to the life cycle of these additions. So for example, we might be running some process or utilizing some class that needs to be stopped or canceled when our activity or fragment is destroyed. In these cases, we can utilize what are known as side effects in Compose. Now, there are many side effects available in Compose, but in terms of interrupt with Android classes, the disposable effect is an important one. Using disposable effects, we can work with composables that require disposal. So the disposable effect takes a key, which is used to determine when this effect should be run. If we have some class or reference that might be changing, we can provide that as the key so that our disposable effect is run whenever that changes. If that's not the case, then we can simply pass some form of constant value to run the effect only a single time. In the example on the screen, I have a custom view that takes a listener. However, when this composable is decomposed, I want to be sure that we avoid any possible leaks. So for this, I provide an Android view reference as the key for my effect, as my view never changes, so we don't need to worry about this being relaunched. Followed by utilizing the onDispose callback of the disposable effect to tear down my listener. So I am now safe from having leaks from my listener, and by placing this inside of the onDispose callback. So this, however, is a simple example. In some cases, you might need to integrate lifecycle observers to adhere to specific events, like on pause and so on. But in these cases, we would still be able to utilize the disposable side effect to manage our composable and its lifecycle. Again, this is only one example, and I just wanted to introduce this concept. But check out the developer documentation for more information on what side effects are available, and even the Compose samples from Google. There are some nice examples there of how to handle tearing down of specific views, such as maps and so on. So during migration, whenever you're working with state or you're trying to interact with the Android framework, there are likely going to be times when things get tricky or don't quite feel right. And that's okay. Rather than trying to force or wedge things in place, we can follow a simple guideline of flowing data down and passing events up. So to take a simple example, here we need to trigger the launching of an activity when a composable triggers some event. We trigger this activity launching from within our Android UI toolkit code, but trigger this using a callback from within our composable button. So as I mentioned, this is a simple example, but it does demonstrate how we can approach some of these things. The same can be done with state management and other framework interactions. So if in doubt, follow the approach of passing data into composables and flowing events up into the parent. So finally, a lot of composables obtain their theming from theme attributes, taken from the theme that you apply in Compose, or from some form of default if a theme is not set. So it's very likely that you have some form of theming in your application. And the good news is that if you're using the material or app compat themes, there are supporting libraries that allow you to utilize the theming from these inside your composables without needing to recreate and define an entire new Compose theme. So in Compose, we might have a theme defined like so. This wraps our composable content and applies the theme to it. When doing this, we need to provide the attributes that we want to be used in our theme. So this could be colors, shapes, and typography values. The great thing is that using the MDC theme adapter, the composable function will automatically read the theme from the host context and provide them to the material theme. So this means that the material theme in our application that we're currently using can automatically be applied to Compose when using this function. To use the MDC theme adapter, you'll need to add the following dependency. And if you're using an app compat theme, check out the official documentation for notes on a similar library for that use case. So it is possible to customize the values that are used by the MDC theme adapter. And this can be achieved by using the create empty scene function to generate the colors, typography, and shape collections. And then you can use these to pass the material theme function once you've done any kind of customization that you need to. And again, check out the documentation for more information on that. Cool. So that's it from my side. If you're looking to learn more about Jetpack Compose, there's obviously the official documentation and the pathways. I run a website called Compose Academy, and that has snippets, guides, and blog posts which are focused on Jetpack Compose. So please check that out if you're looking to learn more. We're also currently working on our practical Jetpack Compose book, which will be released later this year. And you can sign up for more information on the website if that is something you will be interested in getting hold of when it's available. Cool. So that's it from me. Thanks again for watching. Thanks for being here. Happy to answer any questions on this or Compose. And yeah, go for it.
Hi, Joe. Thank you so much. That was really, really amazing. So we do have some questions for you. Potsani, unfortunately, is having some internet problems, so he couldn't. He was kicked out of StreamYard again. So I'll be asking the questions in the meantime. So our first question is, does Compose to the Android view system work well with the existing app architectures such as MVP, or is there recommended architecture?
Great. Yeah, so Google do recommend or are pushing the MVVM architecture. Doesn't mean you have to use that. Like, it does work well and it's great because a lot of their samples are MVVM, so it makes it helpful to have that as a reference. I know people using Compose of MVI. I haven't seen any MVP examples. I think the difficulty there is it depends how you're managing state. Like, to be honest, I don't think whether you're using MVM, MVI, whatever one makes too much difference. I haven't used MVP, so don't hold me to that. But I think it's mainly about how you manage the state. If you have a single source of truth and how that state is being updated, which I imagine might be more difficult with MVP. So it's probably possible, but probably just a little bit more work to get it right.
Cool. Our next question is, does Jetpack Compose work with data binding in the same way layouts do? Not really sure.
I've never used data binding, but you can't use it with Jetpack Compose. Jetpack Compose doesn't have. It's quite a different concept as well. Like, Jetpack Compose doesn't have the concept of essentially layouts because you're composing the UI. So when you're defining your composables, that's all you have. You don't have like a separate file that references the layout or the content of that. I'm not sure if that answers that, but
I'm sure it does.
Yeah.
Okay. Is there a Git repo that we can see an implementation of using Compose with the classic Android view system discussed in the talk?
Good one. So I don't have one. Maybe that's something. I do have a project that has it in, so maybe that's something I could open source. I think if you go to the official Google Compose samples, they do have some Android view usage. So I can't remember what one. I think it's the Crane app has a map which is using Google Maps, which isn't yet supported by Compose. So they're using that inside of an Android view, and that's a really nice example because they're also handling the life cycle. So we talked about side effects. So that they're using side effects there to manage their life cycle. So that's a good one to check out. I can find a link and post it in the chat.
Cool, thank you. One of our last questions are, what are the best practices to adopt Compose for intermediate developers? So those who don't have so much experience building apps.
So I guess that's a good one. So in terms of Compose adoption, my advice would be to start small and really think of like the simplest places in your app that you can start Compose adoption. So even if you have, I don't know, a button on your screen that is inside of your UI, and using the Compose view to replace that button with a composable button. Even though it might seem like, oh, that's like really simple, like it's just a great way of starting to see how Compose will fit into your existing application. and it's also good for motivation, like seeing something on screen and seeing something build and it work. And yeah, starting small individual components, and then once you've got that initial composer in place and that individual component, you can start building it up from there slowly. The state is where it gets complicated. So if you can start with stateless views, that would be good. So maybe buttons that don't change their content dynamically, and then go from there.
Okay, I actually have a question of my own. So with side effects or effects, do you think that's going to be prohibitively difficult for developers to pick up on what it actually does and what it actually means? Or do you think it's such a sort of like not really main use case that it actually will be okay for everyone to use eventually?
Yeah, so I've used them a bit, but I don't know them extensively. They are, personally, I think they are a bit more on the trickier side.
Yeah.
Like at first, I imagine like if you're doing small, simple things, like you might not need them. But as soon as you like, there's I think there's like 8 or 10 different side effects which can be done for different things. So like if you want to trigger something on a recomposition, or if you want to trigger something on a life cycle change, or yeah, I think they'll be worth learning. And the way I discovered them was because I can't remember what I was trying to do. I only wanted to run something once on composition, and I couldn't work out how to do it. And then I came across side effects, and that was what I needed. So I mean, there is, the documentation's good, and there's official documentation for it, and there's also a really good blog post which I can put in the chat as well. It's worth reading. But yeah, I think they'd be worth learning, but I wouldn't say they're needed right away, as it could be a little bit overwhelming.
Yes, I think so too. Okay, Joe, it looks like that's most of our questions. Thank you so much for speaking. It was amazing to have you and Eliza speaking at our meetup. We were so proud that you actually made it, and that we could host you. And just thank you so much from the bottom of our hearts. And we hope that you have a lovely day further. And thank you again.
Thanks for having me. It's been great. Really enjoyed it.
Cool. It looks like Patani is back, so let's join him again. Thank you, Joe. Bye.
Okay, thanks so much, Joe and Eliza, and thank you so much, guys, for joining us. So we will move on to the final part of our meetup. We'd like you to enter this competition by one of our sponsors, Overson, and just fill up your details and then stand a chance to win some really cool swag from Overson. Alternatively, you can use this code here and then follow the instructions and then fill up the details. And then from there, we also have our meetup survey. You can use this to rate our today's session, and then you can also stand a chance to win a Google Mini item, and you can also use the link, the code to access the doc as well. Thanks so much, everyone. Hope you enjoy the session.